Welcome to Types of Controls, Wired and Wireless. We'll look at network lighting control systems and how they're defined by the DesignLights Consortium. We'll talk about benefits of using these systems, wired versus wireless communication, controllers as opposed to digital LED drivers. We'll look at the benefits and disadvantages of using a wired versus a wireless system. We'll talk about situations where you might use some kind of hybrid of that, and we'll touch on cybersecurity. So as defined by the DesignLights Consortium, network lighting controls are the combination of sensors, network interfaces, and controllers, and those make changes in light fixtures. At the end of the presentation, we'll have a slide which will show you how to get access to the qualified products list, and a separate video will actually give you a demonstration of how the qualified products list works and how beneficial of a tool that is. One of the really big benefits of using a network lighting control system is that it can control all the lights and all the zones in any room, floor, building, or even campus. Another fantastic benefit of using a network system is that you can typically create schedules and sometimes even control profiles that predefine how lights and even control devices behave, and you can ask them to behave differently at different times of the day or different days of the week. Another huge benefit of using a networked system is that it's very easy to display and even record energy usage. So this is a screenshot from a system showing the previous 30 days of energy usage. And on the top is the maximum connected load. Basically, that means if all lights were on at full all the time. Down near the bottom, the darker blue bars show the actual power usage, and the difference is the energy savings. And if you look in the box in the upper left, it says that the savings over the previous month was 79% from the baseline of the maximum connected load. So that's a huge savings, and we can get that because we have this system where we've tweaked all of our variables and used as many control strategies as we can. Another cool benefit of using a network lighting control system is that we may very well be able to interface this network system with other network systems. For example, heating, ventilation, air conditioning systems, or a BMS system, building management system, or a fire alarm system, or a security system. So sometimes this requires additional hardware, like what you see in the middle, and it also may require you to have some programming in a different protocol or language. In this case, it's called BACnet, which is typically used by HVAC systems. The question of wired versus wireless controls has to do with how you establish the network. So all of the devices that you see listed here can be connected to the network either wirelessly or via wires. It depends on the system. Some systems can allow you to do both at the same time, or either. So you need to check with each system you might be considering using. And we'll touch on controllers a little bit more in a subsequent slide. Remember that fixtures are always wired in terms of power wiring, because otherwise they won't light up, right? So the question of wired versus wireless is really about how you make the connection to the network. It's not about the power side, powering the actual lights. So the controller is one of the most important pieces of the system, because that's the component that has a relay that will switch the fixture on or off. It also has circuitry that will send a dimming signal to the fixture. Then, lastly, it also has some method of connecting to the network that can be either wired or wirelessly. These are typically installed in the fixture, and if these are purchased on an OEM basis by the fixture manufacturer and they're pre-installed in the fixture manufacturer's factory, they can actually bench test every fixture to make sure that they've installed them correctly. It's much easier to do that than to have to do that in the field by the electrical contractor. It's very easy to know that every fixture they ship out works perfectly when it leaves the factory. These may have to be remotely installed in the plenum, for example. That may depend on whether or not there's enough space in the fixture housing to contain these, so it's possible to remotely install them. And some systems have larger and higher amperage centralized controllers. If you were to do that, then the fixtures themselves wouldn't have individual addresses. So manufacturers often offer these in different amperages to meet the needs that you have in your particular project. This is just one example of a controller, and if we look at this, it's got a black wire, so power comes into the device through the black wire, goes out on the neutral wire. That means that there's power coming into this controller, and that's because there's circuitry and little LED indicator lamps and also a radio inside. Those need power. The red wire, on the other hand, is going out to the light fixtures, right? That's the load side. That's the typical convention in the lighting industry. That red means it's going out to the load. On the bottom are push-in connectors for some low voltage wires, in this case violet and pink, and that's to connect to the fixture to send the 0 to 10 volt dimming signal. So this controller, because it's establishing a wireless connection to the network, not only has an internal radio, but it also has an antenna. Normally it's tucked into that slot that you see there. If there's any issue with the signal getting back to the gateway, you can pull that out of the slot, let it hang down, and that may help to establish the wireless connection. And then finally, these guys actually put some buttons on the face of this device to allow the electricians to check the on-off function and the dimming. That will verify that the wiring is all correct before they leave the job site. So there are digital LED drivers available, and digital LED drivers contain an integral on-off switching function. Because they have the on-off switching function, you can actually eliminate the need to have a separate controller and possibly reduce the cost and complexity of the installation. So these devices use digital language in the network. They don't use analog protocols such as 0 to 10 volt to send a dimming signal. It's different. They're purely using a digital signal to talk throughout the network, and these will directly tell the LEDs to dim. So some of these digital drivers use what's called an open standard protocol, such as DALI, that means Digital Addressable Lighting Interface, but others use a proprietary protocol. So we've got some line voltage wires coming into this device, secondary low voltage wires up on the upper right going to the LEDs themselves, and then we have a place to connect low voltage wires to create the network, in this case a DALI network. So in terms of advantages of wired systems, there's a general perception that they're less prone to hacking than wireless controls. Many IT professionals would argue that point, but that's been the typical perception in our industry. These are typically easy to install in new construction projects because you have to run power wiring anyway, so you should be able to run these additional wires too. Shouldn't be that big of a deal. And generally, you shouldn't have to worry too much about signal propagation. And that's because that's an issue that's associated with wireless systems, where we don't know how the waves are bouncing around the space. Here, we know they're going through the wires. In terms of disadvantages, you'll, of course, have some additional materials costs for the extra wire and possibly extra labor costs as well. So as an example of a wired system, here we've got 2 floors of a building. Each floor has a whole bunch of 1x4 LED troughers. There are also some round downlights here and there, and those can also be connected to the network. We've got wall-mounted switches, and notice that because this is a wired system, there's got to be some kind of wired connection back to the network. In this case, we have separate sensors, occupancy sensors and photo sensors. They're not installed in the fixtures. Those have to be connected to the network as well. Remember that we still need to have normal lighting panels, distribution panels for power to go to the fixtures, right? But those are different than the gateways for the actual network lighting control system. So the black lines in these drawings, in some cases, represent power and network, and in some cases, they only represent network. We don't know from looking at the drawing, but you know that the fixtures need both power as well as the signal from the network. And if you notice, they actually show the gateways getting connected to a server in a floor below via blue wires to distinguish them from the black wires that are going out to each floor, some of which carry power. There are some advantages to using a wireless system. One of them is that they're very easy to install in new or retrofit construction projects, and I should say in particular in retrofit projects. So an example would be that if you have a retrofit project where you're simply going to swap fixtures one for one, and the new fixtures have pre-installed wireless controllers, then you wouldn't have to install anything else except for sensors and switches. If you also had pre-installed sensors in each fixture, that would be called an LLLC system, meaning luminaire level lighting controls. And then literally all the contractor has to do is to swap the fixtures and they're done. So there's potentially substantially lower materials and installation cost. Is the wireless system more prone to hacking than a wired system? Again, IT professionals would probably argue that at this point, but that's been the general perception for a long time. Remember that in order to get onto the DLC qualified products list, you have to demonstrate that you have achieved some kind of cybersecurity certification. We'll talk more about that in a moment. So signal propagation can potentially be problematic with wireless communication, in particular through things like floors or concrete walls, or even just through drywall partitions. And a final note is try not to exceed the recommended number of devices that get connected to a gateway, because the manufacturers have those recommended limits for a reason. So an example of a wireless network lighting control system looks like this. We may have high bay LED fixtures on an interior. We may have exterior floodlights somewhere outside. We may even have those post-op lights that you see in the drawing below. We may also have some lensed interior lights in interior spaces. Those are all connected to the system via a wireless gateway. And then those all get connected to a centrally located server. Finally, there has to be some way to talk to the system to commission it. And in this case, it uses a mobile app that communicates with the server for commissioning and operation and so forth. There may be situations where you might want to use a hybrid, where certain components are connected to the system with wires, other connected wirelessly. So an example might be to connect the fixtures with the network via wires, because remember, you have to run power wires to the fixtures anyway, but you might decide to use wireless connections for the sensors and switches. So these sensors and switches are usually battery operated, and if they have radios in them, they can connect to a wireless gateway. Therefore, you won't have to run additional wire through the plenum or down the walls to connect sensors and switches. So that's an interesting benefit of systems that allow you to use a hybrid configuration. So here's what another hybrid example might look like. On the second floor, we've got fixtures and sensors which are connected via wires back to some central location. We also have interfaces like wall switches connected by wires to a gateway. And then that gateway will be connected to the server, in this case located on the first floor. On the first floor, for some reason, they've chosen to use a wireless system, so the fixtures and sensors are connected via radio. So are the switches. So here's the wireless gateway for the devices on the first floor. And then both gateways, those on each floor, get connected back to the server down here located on the first floor, as well as the interface to the server to allow you to commission this system. I mentioned that cybersecurity is important, and the DesignLights Consortium has requirements that you have at least one certification showing that you have used a methodology for testing the system and its vulnerability to hacking. So this is just a partial listing, and we'll explore this in much greater depth in another video. But this shows you that the industry is taking cybersecurity very seriously. And finally, to access the DesignLights Consortium's Network Lighting Controls Qualified Products List, or NLCs, this is the procedure that you use, and follow this procedure to get onto the website, create a free account, and then start using the Qualified Products List. And in another video, I'll demonstrate that. Thank you for watching this video on types of controls, wired and wireless.